So today we're going to be doing this Harvard WT44. It's got an intact error, we won't be bothering. It doesn't have a digital display, but instead has a bezel which you can see the numbers through. We've powered it up, but you need to be aware that the connector is negative inner, positive outer. Don't blow the radio up. And it's a 12 volt radio. Not 13.8 volts. Okay, we've got a circuit diagram. It's one of my own sets. It's going to transmit. Straight away it's actually doing more than 3 watts. It's actually doing 3.1. This is fun to change channel. Removes cobweb. Channel 1. Channel 1 is doing 2.8 watts. And channel 40 is doing 2.8 watts. Back to channel 20. Pop it on low power. It's doing 520 milliwatts. Back to full power. And the current consumption is 656 milliamps. Transmitter deviation. Oh, we're in the wrong mode. Wallow. Looks to be around 1.8. We'll verify that with the other. We won't be doing VCO. And the frequency, let's go over to the frequency counter. I'm not showing you any of this, am I? And the frequency is supposed to be 791, 27, 79125. We're on the right channel. No, it's just a bleed over box. So it's off channel. It's 2779055. So it's so far out. Right, what we'll now do immediately is we'll put it on frequency, otherwise we're going to be faffing around compensating. It's supposed to be a 4 watt radio. Let's just do the free. It's a nice quality trimmer capacitor, this. Good grief, that's got some swing. I thought we'd be struggling here to get it anywhere near. I bet you could run this on some rather iffy crystals. So there's your crystal. 20 picofarads for the trimmer capacitor. Right, so we're now on frequency. So I won't have to compensate with the signal generator. Let's get it spot on. And let's see what we've got on the sign. How do we connect the cyanide meter to this? Yeah, right. Well, we have to dismantle the radio. So I think what we'll do is we'll go through some of the other things first. So it doesn't have a meter, doesn't have a meter. I'm going to say meter lamp because it does have that LED. We can do squelch. I think it's a wishy-washy squelch if I remember rightly on this. It's 15, 16, 17 for tight. It's a bit weak. And the threshold, I hope that's adjustable because it's lousy. It's 2.9. It's dreadful. Hoping the detector's out and that's fixable. Right, we're going to have to start with transmit, and then we'll have to take the board out to get to the speaker in order to do that test with the receive. So let's get on with that. We'll go over to there. Let's see if we can do a tune-up. So we'll look at the circuit diagram. So what have we got which is adjustable? Well, not a lot. How is that? It could be adjustable. 7, 8, 9, 10, 11, starting at 11. But how do we find those on a board which is, you know, if that's 10, I bet that's 11, so I think it's going to be 11. You've got 3 there though, haven't you? I think that's going to be transmit as well. Let's start here. So that's definite peak. That's definite peak. We've touched that one. We won't. That feels like VCO. Don't touch that one. So far everything's been spot on. A bit warm. I mean a bit what we've got, there's a rubber band in there to stop it shifting, and the rubber band's rotted. I'm in danger. I have broken the coil. So it's a 3-watt set. So I'm not going to, it's my set, I don't need to extract that and find a new one from somewhere. So we can just leave that. But it broke because of the elastic band. So there was no other way to do that. If it was customer set, we'd have to remove the coil, remove the broken core, and get another core from elsewhere with it extracted. I don't think it's going to make any difference to the power. It's doing 3 watts. We could say, sorry, 3.1, isn't it? It's 3.1. So that's where it is. So where is it on the other channels now? So on channel 1 it's 3 watts. And channel 40 it's 3 watts. And on channel 20 it's 3.1. So it's balanced it up. Low power isn't an adjustable thing, so I expect it's still wherever it was. It's 510 milliwatts. Should be 400 milliwatts, so that's a bit naughty. So let's see what presets we've got. We've got one there, we've got one there. See if we can find these in the circuit. So we've got squelch adjust, thank goodness. And the other one must be deviation. So here's the logic. Here's our receiver. There's the 455 IF. There's a preset. So chances are that that's going to be for squelch. And the only other preset is there. We know that's in the lower stages of the transmitter, so chances are that's going to be deviation. What we'll do, we'll plug this into the test bench behind me, and we'll just make sure that deviation is somewhere sensible. So this is where it gets interesting, because I've got to kind of pick it up and talk. Wow, it's a bit low. So after telling you what I told you, the deviation control was actually what I thought was the squelch control. But you see how my mind's working? You can see how I'm sitting on the lead and pulling this set on the floor. The deviation turned out to be there. I really didn't expect that. But the things aren't labelled, it's all guesswork. So as far as I'm concerned, that's transmit done. And that works fine. I'm going to have to dismantle the sets or cut the power, because we need to get to the speaker connections. And this is one of the things about sets which don't have external speaker facilities, earphone, socket, whatever. Very, very inconvenient. Don't make the mistake I did first time round. I took those 2 screws out. Or am I still taking the wrong ones out? You've got to take the knobs off, haven't you? No, I think we do take those off. So So the reason we weren't getting anywhere with that screw is because it snapped away at some point. Just imagine making one of these. I'm guessing that they put about 5 parts in and move it down the conveyor, and then somebody else puts 5 parts in. So that green wire is our speaker. So what we're going to do, put a crocodile clip on. We need the power connector back in. We need the aerial connector back in. I'm hoping we can pick the earth up through the test instruments and just take one wire to our synod meter. I mean, considering the transmitter was virtually spot on, it was just needed balancing up. I'm not expecting there to be much difference here, but I just don't like the way the squelch is and wondering if the detector's out. So we'll clip that onto the speaker there, and then kind of put this somewhere like back and power it back up. I daren't adjust the volume, but I'm going to have to, aren't I? So what we'll do, we'll put the oscilloscope on, adjust the volume. No, it's not nice, is it? Adjust the volume, I'm going to have to adjust the oscilloscope. So our detector I think is going to be this one. Oh, what an improvement. Fantastic. And that should bring the squelch up. I've gone and adjusted that, of course, and not done a sensitivity check, have I? Let's turn the squelch down. So over to the synod meter. We've currently got 1 microvolt for 12 dB. And 0.85. If we'll do 23. So that's fine. We'll still go through it though. Back to 100 microvolts. Turn the volume down. So we've done detector. Let's recheck. And then the trouble is it goes quieter as you turn the signal down. So that's going to be receive. And that IF. That's our peak. It's a very simplistic receiver. I think we've got that and that'll be it. That's it. Nothing more. This is the loading coil for the telescopic aerial. So I'll see if we can get into that with it and read it with the field strength meter. Let's see what we've now got. Probably no difference whatsoever. So for 12 dB, I'm in the wrong scale. I've actually lost sensitivity, but it's set right. It's now at 1.2 microvolts. 10 dB. It's now 0.95. And for that it's still 3. This sometimes happens when you actually line it up right. If we'd have tried running it with that slightly better sensitivity with it being off tune, people would have sounded off frequency and garbled, even though the sensitivity was better. But I can still hear this radio at 0.25 microvolts, so you know, it's not like it's deaf, it's just that it's noisy with it. So hopefully that other preset, which I swore on a stack of Bibles was going to be deviation, hopefully that will be squelch. So let's turn squelch to full. Let's put this to the attenuator controls. See if we can fiddle with this. VR5, let's just have a look at this circuit. It's just having no, it's just making no effect. It's attenuator adjust. It does. Wow. VR5 attenuator adjust. So go back to transmit. Go to low power. I didn't see that because it's in a funny position on the circuit. There you go. Absolutely as per manual, 400 milliwatts. So there you go. So where is squelch? Well, there's another preset just under the heatsink there. There we are. So I've now got that at full, and full gives us a better 13.5. No. Are we at full? Yeah. It's still 17, there's no difference. So I've jacked it up, but it's still 17. Let's see where we are at the other end. It's probably made it worse. So turn the squelch down. Set threshold on the radio. Switch the signal generator back on. That really is dreadful. It's 4.4. We've got to have better than that, so we've got to drop the top end squelch down. This will not work round Scratchy Corner if we have it as bad as that. So let's turn it down a bit to there. So recheck. Set threshold. It's back to 2.9. So we can't improve on what it came set at. So it's going to struggle. It's going to be. I think it's going to possibly be a bit in and out, round scratchy corner. At the end of the day, it's a walkie-talkie. It's a cheap set. They were £99 these, but the realistic was 120, wasn't it? So you know they weren't as cheap as the Harvard 410. So we'll be clear again. Transmit. There. We're going to do this in a moment with the field strength meter. Receive the front end, the IFs, and the detector. Say that again. Detector, front end, IF, and that will be part of the front end or the multiplier chain. Right, we'll put it back together. Turn it off at the mains. So I've got it back in the case. So the next thing to do is to find a field strength meter of some description. Right, we'll use this one. It doesn't have a little aerial. We'll just put a crocodile clip on the back of it. So where there should be an aerial, we'll put there. I'll put it like that so we can all see it. I've got to pull up this telescopic. I think we'll set this on low power so we don't have any possibility of damaging the output. Power it back up. So this time we're not on test instruments, we're on this aerial. Turn the volume down. Which would have helped if I'd put the knobs back on. Right. So key up. Let's get this in such a way that we can get a reading. So we've got a reading there, haven't we? When I key up, we've got that reading. So the moment we go to full power, you'll see that changes. So the idea of this is we're loading coil, we want the maximum going out into the aerial. I hope that's not another one that's going to break, but you see it's got another solid, it's just shifted a bit. It's not wax, I wish it would, it'd be better off using wax than a rubber band that can fail. Oh look. So we've actually improved that. Power off again. I'm going to have to do the glue gun thing. I'll probably do that after we've done the on the air test. So we'll clip it back together for now and simply not put the screw in, which was doing nothing anyway. That's probably why it's been a gaping set. There we go, it's gone back together. So if I switch it back on, can we actually see? I'm going to zoom in on that. And there, hey presto, it's got the channels. So what we'll do, we'll put the aerial on instead of the test gear. Remember, these are a bleed over box. One nano Roger, or in low power, 1 nano Roger. We'll flick through the channels. He's probably doing about 50 watts. It's bound to be the burner brigade. And I expect he's in Nottingham. Right, well there we go, the Harvard WT44. To be honest, the squelch is picking that up rather well, but that, I say, maybe is illegal power level. It won't be on 4 watts. So we've got the circuit, we've got very little else. We've done the deviation. It was 2.2 to 2.5.
Well, let me know then when you want it. You've got it and I'll pick it up for you. It won't be today though.
So he's going out. Perhaps someone will tell me why they won't bother changing channel, or is it just have more and more power so they don't need to change channel? Right, so thanks for watching Harvard WT44. Never done one of these on a video here before, but we have seen them before.